Welcome back, and we're going to look at some additional formulas. These ones are less common, but are still important, at least as we work our way through trigonometry. So um, we want to actually prove these formulas using what we already know about angle addition. So for example, with sine, right, you can do this as sine, you can represent this as sine of u plus u. These are each angles. And then via angle addition, right, we can say that this is sine of u cosine of u plus cosine of u sine of u. And these are actually the same thing, right? We have the same term repeated, and so this would simplify to 2 sine u cosine u. Okay, so, and I'll maybe just add parentheses around the angles to make it clear that that's what I mean. But at the end of the day, we have sine 2u is equal to 2 sine u cosine u. Okay, if we do the same thing with cosine u plus u, okay, this was cosine of u plus, or times cosine of u minus sine of u sine of u. And so this ends up being cosine squared of u minus sine squared of u. That is one version, okay? You might remember that we have the Pythagorean theorem, or the Pythagorean identity, so we could say, sine squared of u plus cosine squared of u is equal to 1. And so with that identity, this can take on different forms. So it could be 1 minus 2 sine squared u. Okay, so we might solve for cosine in this identity and substitute it, or we could also solve for sine, substitute it in, and you get 2 cosine squared u minus 1. So any one of these three versions of cosine 2u, so a double angle, are valid. Okay, tangent, you can do the same thing, so tangent of u plus u, and so I'm going to write in the details here, and you can copy them down. And there you go. Okay, just kind of following through the angle addition for tangent. So these properties or these identities, the things that we're saying, when I use the term identity, I mean that cosine of 2u, for instance, is the same as cosine squared u minus sine squared u, so they are the same thing. So I can move between them at will, okay? So double angle formulas. The other formulas that we're going to work with, and I'll just kind of get to those right now, they're actually related to those double angle formulas that we just saw. So for instance, if I look at the identity cosine 2u is equal to 1 minus 2 sine squared u, and let's say I want to solve for sine squared, let's see what we get. So I'd subtract 1, right? So I had cosine 2 theta minus 1 is equal to negative 2 sine squared theta, and then divide by negative 2. Okay, so then that switches the order. I get 1 minus cosine of 2 theta all over 2, and that would equal to sine squared of theta. And maybe I just want to solve for sine, and if I do that, I'd have to do a square root, right? So I'd say, I'd say, plus and minus, right? 1 minus cosine 2 theta all over 2 is equal to sine theta. Okay, so this gives us a nice way to relate an angle with twice its angle. Okay, or equivalently, we could call this a half angle formula in the sense that if we're given, 2 theta, so that might be given, then we find half of that angle. Okay, theta is half of 2 theta. Okay, and so with that, we can do similar formulas. The power reducing formulas, these are less common. Okay, but we actually kind of find those on the way to find the half angle formulas, okay? So because you would just square root each of the power reducing formulas to get the half angle formulas effectively, okay? One thing that I want to mention is there was that plus and minus out in front, right? To choose whether it is plus or minus, we need to look at the quadrant where theta is. Okay, that's a super important part. Okay, and then make the choice based on that. So for instance, a lot of us still remember ASTC, so all students in calculus, and that helps us determine, where different trig functions are positive. So if theta is an angle in quadrant 2 and I'm working with sine, I would choose the plus, for instance. If I'm working still in quadrant 2 but I'm working with cosine, then I would choose the minus here. Okay, but it is based on theta, not on 2 theta. All right, something to be aware of. Okay, so this video is just meant to introduce these formulas. You're probably like, oh my goodness, this is a lot of formulas. It is. Okay, keep a list of them, keep track of them, and we'll get practice with them in the videos coming up.